KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we start with exercise problem 27. See here, first I will read the problem, then we will go for solution. Okay, see here, in this problem exercise, that is what 27, an angular magnification in the bracket magnifying power, in the bracket magnifying power of 30, that is what the size 30x like that, right, is desired using an objective of focal length 1.25 centimeters, 1.25 centimeters, right, and an eyepiece of focal length 5 centimeters, full stop. How will you set up the compound microscope? How will you set up the compound microscope, right? So what is compound microscope? What is the purpose of compound microscope? And what about the objective lens and eye lens, focal length in case of compound microscope, right? So which type of lens, the lens having how much focal length, that is what the larger focal length or smaller focal length is close to the eye, okay, and what is the distance between the compound distance between the two lenses, that is what eye lens and objective lens, right? So these are all we know, because in the last chapter Ray Optics, when we were in a discussion about optical instruments, right, such as microscope and telescope. In microscope means basically we discussed and we concentrated there simple microscope, after that compound microscope, right, and telescope means, that is what two types of telescopes are there, terrestrial telescope and astronomical telescope. We also discussed reflecting telescope, okay, right. So when we are going to see a problem related to one particular optical instrument, we have to get the ray diagram of that particular optical instrument into our mind. For example, here this problem is related to compound microscope, right? So whenever we are going to talk about compound microscope, we have to get the ray diagram of compound microscope into our mind. Okay, then the problem will be very easy. Okay, right. See this. In this problem, they have given angular magnification, that is what magnifying power, that is what 30, right, almost 30. That is desired using an objective, of focal length 1.25 centimeters, 1.25 centimeters, and an eyepiece of focal length 5 centimeters, full stop. How will you set up the compound microscope? How will you set up the compound microscope means he is asking to find separation between the objective and eyepiece. Separation between the objective and eyepiece side. So once if you look at the given things, given quantities, so small m is equal to 30. Small m is equal to 30, and afterwards here objective focal length is 1.25 centimeters, right? It is what f0, and eyepiece of focal length 5 centimeters. It is what fe. Okay, right. So these are the things given: small m, f0, fe given, and asking to find, that is what separation between the objective and eyepiece, that is equal to modulus of UE plus modulus of V naught. Okay, that is the separation between the two lens, that is what objective and eyepiece. So that is the main thing to set up the compound microscope, right? He is asking to find setup of the compound microscope means we have to find separation between the objective and eyepiece. See here, usage, that is the final image, right? Here if you observe carefully, we assume the microscope in common usage. We assume the microscope in common usage, that is final image is formed at the least distance of distinct vision. Final image is formed at the least distance of distinct vision. You know very well, when the object is at least distance of distinct vision, you can observe that image clearly. So regarding the stress point of view, otherwise regarding the sufficient amount of light point of view, otherwise the field of view point of view, whatever it may be, when the image is formed at the least distance of distinct vision, right? So that is what D is equal to 25 centimeters and FE is equal to 5 centimeters. Okay, and angular magnification of the eyepiece, that is ME is equal to, formula is 1 plus D by FE. So by substituting all these things, that is what D value and FE value, you will get it as 6, right? It is what ME. And you know very well, total magnification small m is equal to m naught ME. It is what the magnification is the objective lens. It is what the magnification is the eye lens. But total magnification small m is equal to m naught ME, right? So therefore, angular magnification of the objective, it is what angular magnification of the eyepiece. Now, if you want to find angular magnification of the objective, that is m naught is equal to m by ME. That is, m is already given, it is what 30 by ME is 6. So 30 by 6 is equal to 5. Okay, it is what the angular magnification of the objective. Next, say this: as real image is formed by the objective, as real image is formed by the objective, therefore real image formed by the objective, right? Therefore m naught is equal to V naught by U naught, that is equal to minus 5. See here. Okay, so when V naught by U naught is equal to minus 5, you can write that V naught is equal to minus 5 U naught, and already they have given f naught as 1.25 cm. By using this formula, that is what 1 by V naught minus 1 by U naught is equal to 1 by f naught, right? So here 1 by V naught means what? Minus 5 U naught, no? Minus 1 by U naught is equal to 1 by 1.25, right? So by solving this, you will get it as U naught is equal to minus 1.5 centimeters, right? So it is what U naught is equal to minus 1.5 centimeters, right? So the object, thus the object should be held at 1.5 centimeters in front of the objective lens. Really, object distance is what? Distance of the object from, okay, object center or lens generally, okay, object center, right? So that we found now, which is what the U naught is equal to minus 1.5 centimeters, right? So that only he is saying. Thus the object should be held at 1.5 centimeters in front of the objective lens. Okay, see here. Also, V naught is equal to minus 5 U naught. Also, see here. Here we got it, no? V naught is equal to minus 5 U naught, right? So if you know the U naught value, you can find V naught, no? Because just you have to multiply with minus 5. So V naught is equal to minus 5 U naught, right? So minus 5 into, already U naught is equal to minus 1.5, minus into minus plus, so it will be finally 7.5 centimeters. 7.5 centimeters is the V naught. Right. Next, by using the same lens formula, that is the relation among f, small u and small v, focal length, object distance and image distance, that is what 1 by VE minus 1 by UE is equal to 1 by FE. So we are writing UE as a subject, that is what 1 by UE is equal to 1 by VE minus 1 by FE. Okay, right. Okay, So when it is 1 by UE is equal 1 by VE minus 1 by FE, substitute the things. That is what they have given, right? You know, that is what FE is here they have given, that is 5 centimeters, right? Similarly, VE, right? So by substituting the values of FE and VE, you will get it as minus 6 by 25, minus 6 by 25. Okay. So here already I told you, FE is that is what 5 and VE is 25. VE is 25, right? So by writing this, because of sign convention, it is what 1 by minus 25 will be here, and minus here 1 by 5 will become. So when you do this mathematical calculation, you will get it as minus 6 by 25, right? So finally here our requirement is to find UE. So because 1 by UE is equal to minus 6 by 25, but UE is equal to minus 25 by 6, that is equal to minus 4.17 centimeters, minus 4.17 centimeter, right? It is what the value of UE. Okay. You know, that is what the separation between the objective and eyepiece, separation between the objective and eyepiece is modulus of UE plus modulus of V0, right? So here you have to imagine the compound microscope. You have to imagine the compound microscope, right? That is what length of the tube, that is what modulus of UE plus modulus of V0 is equal to, it is what 4.17, it is what 7.5, finally it is 11.67 centimeters, 11.67 centimeters, right? It is so based on this distance, that is what the gap or the separation between the objective and eyepiece, that is the main thing, no? That is the main thing. See, while set up the compound microscope, okay, right? So in this problem, he is asking to find the separation between the objective and eyepiece. That is what, how will you set up the compound microscope? That we found. Next problem, see here. So it is problem number 28. See, a small telescope has an objective length of focal length 140 centimeters. That is what immediately you might have got it. That is what F0 is equal to 140 centimeters, and an eyepiece of focal length, right? FE is 5 centimeters. Full stop. What is the magnifying power of the telescope for viewing distant objects? The question is, what is the magnifying power of the telescope for viewing distant objects when there are two things, A and B. So A is the telescope is in normal adjustment. The telescope is in normal adjustment. That is when the final image is at infinity. When the final image is at infinity. Okay. Next, B is the final image is formed at the least distance of distinct vision. That is what 25 centimeters. The final image is formed at the least distance of distinct vision. That is what 25 centimeters. 25 centimeters, right? So two things. In two cases we have to find. In two cases we have to find the magnifying power of the telescope, right? So obviously, generally, that is what we are writing first given things. That is what F0 and Fe. First A. In normal adjustment, magnifying power small m is equal to F0 by Fe. F0 by Fe, right? F0 by Fe, that is what 140 by 5. 140 by 5, that is equal to 28. Okay, you do this division, you will get it as 28. 28 is the magnifying power when the telescope is normal adjustment. Okay, based on the given values we found, that is what F0 and Fe. The formula is here MP means magnifying power. Magnifying power small m is equal to F0 by Fe. Okay, right. Next B. When the final image is formed at the least distance of distinct vision. When the final image is formed at the least distance of distinct vision. That is what least distance of distinct vision means 25 centimeters, no, that only written in the bracket, that is what 25 centimeters. Now small m is equal to f naught by fe into 1 plus fe by d, 1 plus fe by d, right. So the things already we know, that is what is f naught, what is fe and what is d, right. So 140 divided by 5 into 1 plus 5 by 25, 1 plus 5 by 25, right. So it is 5 1 ja and 5 5 ja, right. It is what 1 plus 1 by 5, and here is also 140 by 5, right. 140 by 5 means it is 28 into here this will come as 1.2, 1.2, right. So then finally we will get it as 33.6, 33.6, right. So when it is 140 by 5, when it is 1.2, it will be 33.6. It is the magnifying power when the final image is formed at the least distance of distinct vision, right. So in this whole problem he is asking the magnifying power of the telescope at two different situations. The one is when the telescope is in normal adjustment, another one is when the final image is formed at the least distance of distinct vision, right. So in these two situations we found, right, we found that what is the magnifying power based on the given things, that is what f naught and fe, and that is capitally already we know, that is 25 centimeters, like a constant. Next, now we are going to see next exercise problem, that is 29. So here three things are there, A, B, C. So all we have to answer, right. So we will go through step by step. First the A, right. For the telescope described in exercise 9.28a, what is the separation between the objective lens and eyepiece, right. What is the separation between the objective lens and eyepiece? Okay. So he is saying that for the telescope described in exercise 9.28a means whatever the values they have given here, that values you can use here, right. So based on that, what is the separation between the objective lens and eyepiece? What is the separation between the objective lens and eyepiece? Okay. So see here, in the normal adjustment, the separation between the objective and eye lens is equal to f naught plus fe, right. So in normal adjustment, the separation between the objective and eye lens is equal to f naught plus fe, that is what 140 plus 5, that is equal to 145 centimeters, right. So I didn't go through B and C. First I explained you only A, and then immediately I am coming to explain the solution, that is what answer, right. But now I am going for B, then I will come to the solution, because if I will explain all these things and hear all the things continuously means you may forget what he is asking in the question, right. That is important, no? Right. Next, B. See this. If this telescope is used to view a 100-meter tall tower, if this telescope is used to view a 100-meter tall tower 3 kilometers away, what is the height of the image of the tower formed by the objective lens, right? If this telescope is used to view a 100-meter tall tower 3 kilometers away, what is the height of the image of the tower formed by the objective lens? Here you keep in mind, that is what tower, the height of the tower is 100 meters, and the distance of the tower is 3 kilometers, right? And asking to find height of the image of the tower, see, angle subtended by the 100 meters tall tower at 3 kilometers away is, that is what alpha, right? You know, when the angle when the angle is small, right, tan alpha is approximately equal to alpha. That is what 100 by 3 into 10 power 3, because it is given in kilometers, but we are taking in meters. So 3 kilometers means 3000 meters, that he is writing 3 into 10 power 3, and moreover this is in meters now, so this also should be in meters. So by doing this calculation, you will get it as 1 by 30 radians. 1 by 30 radians. Okay, here 3 zeros and 2 zeros, 2 zeros will get cancelled, and here the resultant will be 30. So 1 by 30 radians. Next, let h be the height of the image of the tower formed by the objective. Let h be the height of the image of the tower formed by the objective. Full stop. Then angle subtended by the image produced by the objective. The angle subtended by the image produced by the objective will also be equal to alpha. Will also be equal to alpha, and is given by alpha is equal to h by f naught. H by f naught, and f naught value தெரியும், that is what okay, 140, h by 140, and here we want h now, alpha value also we know, that is what 1 by 30. You just write down here, that is what h by 140 is equal to 1 by 30. H by 140 is equal to 1 by 30, so that h is equal to 0 0 will get cancelled now, right? So mathematically 0 0 will get cancelled, and h is equal to 14 by 3. So 14 by 3 means what is that? 4.67 centimeters. 4.67 centimeters, right? 4.67 centimeters. Okay. 4.67 centimeters. Right. Next, C. What is the height of the final image of the tower if it is formed at 25 centimeters? What is the height of the final image of the tower? What is the height of the final image of the tower if it is formed at 25 centimeters? Okay. So he is asking to find the height of the final image. Here we found the height of the, here we found in case of B, we found height of the image by the objective lens, but here height of the final image of the tower if it is formed at 25 centimeters. So generally to view the object clearly, that is what with sufficient amount of light, okay, and with the proper field of view, and to give less amount of stress, right, to avoid the stress while viewing with our naked eye. So to do all these things, to achieve all these things in a comfortable manner, right, generally we are going to see the image when it is at 25 centimeters. That is what least distance of distinct vision. Least distance of distinct vision. Okay, that's what I am saying. Even in case of 27 problem also, I told the same thing, right? That you have to keep in mind, because when I am explaining, you may have doubts why the image is going to form at 25 centimeters, right? So in the beginning of the chapter, that is what Ray Optics, I told you a small experiment. That is what keeping a 30 centimeters wooden scale in front of you. If you close your eye, you keep the scale very close to your eye, what will happen? Are you able to see the scale or not? If you keep at 25 centimeters, what will happen? If you keep more than 25 centimeters, what will happen? Right? So this small experiment makes us to realize the minimum distance between the object and eye is 25 centimeters to observe clearly and without any that is what right, without getting any more stress, right? At the same time, the field of view, proper field of view also, right? And with sufficient amount of light also, right? Light makes us to see the object clearly, whether it is the dimensions or color, whatever it may be. Okay. The same thing is also applicable when we are seeing the image in case of optical instruments. Suppose in our biology lab, you are seeing the leaf in botany. You are seeing the leaf, right? So there you need to see every cell of the leaf, right? You need to observe every part of the leaf, right? when there is no sufficient amount of light, how can you identify? How can you identify, right? That's why sufficient amount of light is also important. Proper field of view is also important, right? At the same time, stress also important, right? Eyes not get more stress. So if it is giving more stress means how can you observe? It is difficult, okay, right? In these points of these and all we have to keep in mind, right? Because when we are solving the problem, we have to realize what is what. Then only we will get the correct answer. That is what situation based problem. See here, what is the height of the final image of the tower if it is formed at 25 centimeters? See this. Magnification produced by the eyepiece. Magnification produced by the eyepiece is ME is equal to 1 plus D by FE, right? So 1 plus D is 25 no, by FE is 5 centimeters, right? So FE is 5 centimeters. Then 1 plus 25 by 5 means it is what 6. Okay. And height of the final image. Height of the final image is equal to H into ME. H into ME. That is what ME is okay 6, but H is 14 by 3. H is 14 by 3, right? So 14 by 3 into this value, that is 6, will give us 28 centimeters. Height of the image as 28 centimeters. Okay. Here we got no H 14 by 3. 14 by 3 or 4.67. Here you can write 4.67 also. 4.67 into 6 means it is 28 centimeters. 28 centimeters is the height of the image. Okay. Right. In this class, we concentrated on 3 problems, 3 exercise problems, 27, 28 and 29. Okay. So in case of 27th problem, we found the separation between the objective and eyepiece, that is equal to modulus of UE plus modulus of V0. Based on the given things, that is what they have given, small m and F0 and Fe. So based on these things, first we found UE, first we found V0 and then we found UE, right? After completion of these two things, by substituting in this formula, that is what mod of UE plus mod of V0, we got it, the separation between the objective and eyepiece as 11.67 centimeters. After that, the next problem, he asked to find magnifying power by giving F0 and Fe, right? And the least distance of distinct vision is 25 centimeters, we know that. Okay. So by using these two, that is what F0 and Fe, we found magnifying power when the telescope is in normal adjustment, that is we got it as 28, and then we also found the magnifying power when the final image is formed at the least distance of distinct vision. With the help of formula, small m is equal to F0 by Fe into 1 plus Fe by D. So that we got it as 33.6, because the magnification of the magnification has no unit, because of having the same quantity in numerator and denominator, we will get the quantity without any unit. There is no unit. Next problem 29, that is also linked to the 28th problem, but here he by giving some other, that is in first case okay, that is what just in normal adjustment the separation between the objective and island, that is F0 plus Fe came as 145 centimeters. But in B and C, in B he asked to find, right, what is the height of the image of the tower formed by the objective lens, right? So that is we found as 1 by 30, okay, right. Finally we found as 4.67 centimeters. The angle, that is what 1 by 30 radians, but finally whatever he is asking, that is height of the image of the tower formed by the objective lens is 4.67 centimeters. At last in C, he is asking what is the height of the final image of the tower when it is of the tower, if it is formed at 25 centimeters, right? So it came as 28 centimeters. Height of the final image as 28 centimeters. Okay, ma? Thank you. In our next class, we will continue.